Okay, when you think about a hacker, you think about a little guy that sits in the basement of his house and do all kind of stuff. This is a geek person, but whenever I give lectures, I say, I'm always saying, listen, I'm not a geek. I have a motorcycle. I have a cool car. So I'm not a geek. I can introduce Irene, which is not a geek. She drove a motorcycle. Now she's a parent, so she's dying. But she still loves good, cool cars. She has a cool car, and she's a great hacker.
So, thank you, Guy, for this introduction. I am actually a super geek. I do sit in my basement and build Linux and do stuff. And, well, I'm not ashamed of being a geek. It's not a bad thing. It's actually a good thing. So, currently, just a little bit about myself. I'm VP Product and Head of Research at Quotium. We deal with application security and code security. Essentially, for the past 10 years and a bit over 10 years, I've been in the security field. I've been doing mostly penetration testing. So essentially, breaking stuff, it's my passion, it's my hobby, it's what I do for a living, and I think it's a great passion and a great hobby. I do specialize in applications, which means basically anything you can think about which is web, from your banking website, e-commerce, your phone, whatever, but also networks and buildings, just because social engineering is really fun. So, all right, let's go. API. So, a quick summary. What I'm going to talk to you about today is about the software delivery process, which is basically the process in which code which developers are writing ends up on the internet. Now, essentially, what I'm going to talk about is that we all trust this chain, the software delivery chain, and trust is a beautiful thing. You're saying all of us are using pretty much the same set of tools to do it, to take our pretty code and push it to production. And again, trust is a beautiful thing. What could possibly go wrong? So let me start by asking you guys, how many of you ever written code in Java? Java code, come on, it's Java code. All right, how many? Please keep your hands up until I encounter something that you actually didn't do or don't do on a regular basis. So Java code, use NetBeans, Eclipse, BlueJ, one of these. Okay, cool. Now download a plugin for your Eclipse. Ever check the checksum to see that what you've downloaded is actually what you wanted to get? All right, and this, how many of you ever took a deep and interested look into the process in which, for example, plugins, open source plugins, are being authorized into the product? And how many of you just say, okay, well, you know, it's on the marketplace.eclipse.com, so that's actually, you know, that's fine. I'm a security expert. I sit at home with a tinfoil hat, but when it comes to checking anything about these things, most of us are just saying, well, you know, they did it. It's going to be okay. And this is the point. So I'm not going to go a lot into this background just because actually a lot of people here touched code and wrote code. But I'm just going to say that the reason we're talking about it is that today we don't have the luxury of saying, okay, let's write software the old-fashioned way. Let's sit home, let's plan the software, let's design, let's write for 3 years, blah, 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 ship it to the market. It doesn't work that way anymore. What we have today is if I'm Amazon and one of my competitors just added a new feature, I cannot wait even a week to add that new feature. I need to add it tomorrow so I can be competitive. And in this competitive market, I need as many tools as I can to automate the software delivery process. And so we're using a lot of stuff that you guys are probably familiar with, Eclipse, GitHub, Hudson Jenkins, and so on and so on. Now, let's look at this process of developer writing something, putting it in the source control, moving it to continuous integration, and then pushing it to production. Well, what are the spots that can be vulnerable here? Pretty much all of them. In any of these spots, something could go terribly wrong. However, we only have 15 minutes of this bullet, and we're not going over the time, and so we're going to focus on something very specific. So all of these points, the dev station, the build server, and so on, can be vulnerable, but we're going to focus on the continuous integration server. How many of you are familiar with the concept of continuous integration? Okay, super quick intro. So basically, in the old days where we had a lot of time to deliver software, the way a project would go is you have 10 developers, they're all working on the same piece of software. Now, I'm writing code, Guy's writing code, Daddy's writing code, and everybody else is writing their own code. Now, one person, and those of you who wrote code know this, can barely get his own code to work. So imagine after writing code for a month or 3 months or half a year, that suddenly we need to make all these different pieces work together. This is what has been officially known as integration hell. This was really terrible. Developers would spend hours at the office, days, weeks, basically trying to get stuff to work together. And from there, together with the agile discipline, the concept of continuous integration was born, where basically what we say is we integrate stuff all the time. So a few people write code, we combine it, and we make sure nothing explodes, and we do it before the developers forget what they wrote, and before there's thousands of lines of code and tens of thousands of lines of code that don't work together. So that's the point of continuous integration. Now, anyone here familiar with Jenkins? Yeah, people who are familiar with continuous integration. Good. So basically, I'm going to use Jenkins as an example, just because it's super popular. It's a very popular continuous integration server. However, it's really important for me to say that I'm not using it as an example because it's open source. Mind you, I don't think that open source is less secure than anything else. If anything, it's the other way around. With open source, I personally can go look at the code and say, okay, is this what I expect it to be? Well, it's not that simple, but basically I can just review what the developers did. If it's not open source, I have basically no idea. So I need to trust the vendor, and we'll talk a bit in the end about what can I do about that. So, my continuous integration server, basically, as we said, developer writes code, commits it, it goes to the continuous integration server, the continuous server does various checks, and combines it all together into one piece of software. Now, what happens is instead of just, taking this code, and I'm focusing the discussion again because we don't have a lot of time on stuff that's compiled. It means on compiled code and not parsed code, just for the sake of fun in this example. So, what happens is instead of just generating a nice binary, it adds something to the process. Now, if we look at our continuous integration server, we say, okay, does it have any vectors? No, it's okay, it's fine. Does it bring any malware with it? No malware, it's pretty good. It passed all the checks that we've done with it. Oh wait, nobody thought to check. Does it mess with the logic of application that it's working on? Now really, it can be anywhere. It can be on the compiler, for example. Again, as I said, I'm using the CI server as an example. The reason I didn't use compilers as an example, it's because it's a damn ugly example. If anyone here, I don't know, in university or something ever wrote a compiler, it's really not a pretty piece of work, and the moment it's working, you pretty much not touch it. So we decided to go with the continuous integration server. Now, why is a good example? Because for me, it's one of the most vulnerable links in the chain, one of the most interesting links in the chain. Again, if we look to the process, you remember it, on the way to production. So somewhere in the middle there is a continuous integration server. And basically, what's better for a hacker than a bot that sits inside the organization between the parts where developers write their code and the parts where it ends up on targets.com, example that comes to mind. So between the parts that you write the code and it ends up on the internet, there's this magical black box. It takes the code, does something, compiles it, and pushes it out. So it's basically, it's supposed to do something to the code. That's why nobody suspects it. Now, it's supposed to change it. Code comes in. Now, if we look at code, most typically, security code reviews are fired if they are part of the automated process and everything is great and perfect and so on. They are fired actually from the CI server. So look at me, your malicious CI server. What would I do? I would take all the sources from all the developers, take everything that everybody has given me, send it for all the security checks. It comes back from the security checks, and then I do my magic. Now, another option, by the way, which I thought about when this is part of the research I'm working on, which covers all of the software chain. So basically, why not touch it post the compilation phase? Anyone have any idea why do I prefer to tamper with the code when it's sourced and not when it's compiled? Absolutely, we're lazy hackers, as you can see over there. We're lazy hackers, we don't do that. As I said, don't touch the compiler, don't touch compile. So just because, well, it's simpler and why work hard? So, what can we do with that? Basically, we're looking at a process where we sit in the middle, where the organization is essentially, a lot of developers are doing stuff, and we can do whatever we want, because we managed to infiltrate to the, I do apologize for using an open source project as an example, but because we infiltrated an open source project. Now, you know how it works? Basically, you contribute to an open source project. They review everything you do really, really, really carefully. Next one. Why don't they actually do? Well, like the first, I don't know, 15 commits, 20 commits, and you know, okay, it's Irene's code, it's fine, you know, let's just go for it. We've seen it, it's okay. We're, again, it's not that we're lazy, we don't have a lot of time. So we're just going to take this code and use it. So if anyone bribes a developer, it can, by the way, it doesn't have to be open source. It can be a vendor developer. Let's look at an organization. Basically, we're looking at the world of cyber threats where people are willing to pay really good money. So what's bribing a developer? It's not such a big deal. And what can we do? So I focus on web applications just because it's common and what everybody's using. What can I do with the backdoors? So first of all, there's the very, very, very simple executing system code. So basically, what can I do? I can do something. Now here, I want to, before we go into that, focus into two vectors and quickly dive into two vectors. So the first vector goes into the advanced persistent threat. I'm targeting a specific organization, a specific website. I know what these guys are doing, and I want to steal money or information specifically from these guys. And that way I can adapt myself to whatever their application is doing because I know their application because I can see it online. Now, the second vector is a bit more of what's called a spray and pray, where basically I just go across a very wide spectrum. I try to manipulate as many websites as I can. I can actually have them call home if I want to let me know that the website has been compromised. There are really many things you can do once you can just really alter source code. So again, the relatively simple, the relatively scalable, the one that suits the very wide distribution method, is just saying, okay, I'm going to either take an existing parameter in a website, so the parameters, I can take an existing parameter and hook to it like a runtime exec function, something like that, something that will actually execute commands. That's one option. Now, it's much more simple than doing something with the actual application logic. Now, with the application logic, I can say, okay, all applications or most applications have login, right? Most websites have a part where we login. So I'm going to identify this login and I'll do something where if I do some magic input, some predefined configuration string, it will log me in as admin. I can also say, basically, there's a lot of standard, as I said, it's all very standardized. Most websites are going to use the same statement APIs. They're going to use the same, they're called reusable components, and they are really massively reused. So I can scan my code for components that I'm familiar with because this website is likely to use them, and then abuse their functionality. Now, this does require a much more sophisticated level of an attacker, so it's less for the lazy hacker, but it is doable. Then again, I can take secure applications and unsecure them. What does it mean? We have today, it's available, I think even as open source project, I don't remember the name, but basically what it does, it takes your application, it goes over the code, and it fixes it to be secure. So if I have SQL injection, it will find all the dynamic statements, and it will change them all to be prepared statements, parameterized queries, blah, blah, blah. So why not do the reverse? There I have this very secure code that somebody works really hard on doing. Let's unsecure it. So that's another option. There are really an endless amount, an infinite amount of possibilities that you can do. There is also an infinite amount of places where you can do it. This is just really a favorite example. Prevention. Just really quickly, it's not very easy to prevent. So, as you can see the examples here, I don't know how many of you had the opportunity to tackle the challenge of decompiling code and trying to compare it to the source. Thank you, François. So basically, and how was it for you? It was fun, right? And when these guys say it was fun, it means it was really, really, really difficult, right? And it's pretty much near impossible. It's definitely very difficult to achieve on a massive scale. Thank you. We can look at stuff like files and access and so on. Again, on the technical level, this is pretty difficult to prevent because we're looking for malware. Okay, we can do that. We can search for backdoors. But it's not easy. It can be done. Not at the source code on the post-compilation level. It is possible to search for backdoors. Again, you're going to say it's very fun to do, to search for backdoors in compiled code. The real solution lies more in the regulation and policy level. What does it mean? It doesn't have to be government. It can be industry or community-initiated policies. For example, I'm going to take Heartbleed just as an example. Okay, I apologize for using Heartbleed in a lecture. I truly apologize for having to do that. But it's really a good example because after the whole OpenSSL Heartbleed thing blew up, everybody said, wait, why are we not funding this? Why are we not paying money? Why are we not checking it? And I said, okay, so the code that everybody is using is going to be tested and regulated and so on. So it's easier to achieve on this level, basically controlling it and checking it. Again, not instead of the technical level, but these two levels pretty much complement each other. The summary is pretty much, well, it's a very interesting attack vector. It's an attack vector that we do not see a lot of yet. The way I see it is going to be the next attack vector because we are protecting endpoint malware and so on and so on and so on. And this is still largely untapped by attackers. It's also super logical, so harder to prevent. Good luck to us all. Thank you very much.